Welcome back, everybody. Let's solve these questions very quickly. Number one, if alpha and beta, that's 1a actually. If alpha and beta are the roots of 2x squared plus 9x plus 12 equals 0, show that the quadratic equation whose roots are alpha minus 1 over alpha and beta minus 1 over beta is 24x squared plus 90x plus 115. Alright, first of all, let's find alpha plus beta and alpha beta from a given equation. Alpha plus beta is minus b over a, and that's minus 9 over 2. Alpha beta is c over a, which is 12 over 2, and that's 6. Now the sum of the new roots is alpha minus 1 over alpha plus beta minus 1 over beta, which is equal to alpha plus beta minus 1 over alpha minus 1 over beta. And that's the same as, I can write that as alpha plus beta minus into bracket 1 over alpha plus 1 over beta, which is equal to alpha plus beta is minus 9. Okay, before I even go to that, let me write alpha plus beta minus into bracket, the LCM here is alpha beta, and this is the same as beta plus alpha. Now this is the same as alpha plus beta is minus 9 over 2 minus open bracket beta plus alpha is the same as alpha plus beta, which is minus 9 over 2 divided by alpha beta, which is 6. So that simply means that's divided by 6, which simply means minus 9 over 2 minus open bracket. Of course, minus 9 over 2 divided by 6 is the same as minus 3 over 4. If you work that out, minus 9 over 2 divided by 6 means times 1 over 6, 3a2, 3a3, and that's minus 3 over 4. So when we simplify further, we're going to get minus 9 over 2 plus 3 over 4, which is the same as that's minus 15 over 4. That's minus 15 over 4. Now the product of the new roots is 1 over alpha times, and the product of the new roots is alpha minus 1 over alpha times beta minus 1 over beta. Those are the new roots, and that's the same as alpha beta, when we open the brackets, minus alpha over beta minus beta over alpha plus 1 over alpha beta. And this is the same as alpha beta minus, or let me write plus 1 over alpha beta minus open bracket alpha over beta plus beta over alpha, which is the same as alpha beta plus 1 over alpha beta minus, let me write that on the next line, open bracket, the LCM of the denominators is alpha beta, that's alpha beta divided by beta is alpha times alpha, that's alpha squared plus alpha beta divided by alpha is beta times beta, that's beta squared, and that's equal to alpha beta plus 1 over alpha beta minus alpha squared plus beta squared is the same as alpha plus beta all squared minus 2 alpha beta all over alpha beta, and that's finally equal to, now we can substitute, alpha beta is 6 plus 1 over alpha beta 1 over 6 minus open bracket alpha plus beta is minus 9 over 2 all squared. I think my bracket is going to be a little longer, minus 2 alpha beta, that's minus 2 times 6 divided by alpha beta, which is 6. and that's simply 6 plus 1 over 6 is 37 over 6 as a whole number. That's 37 over 6 minus, this is going to be 81 over 4 minus 12. Let me just do 81 over 4 minus 12. I'm doing simplifying the numerator of this fraction. 81 over 12, 81 over 4 rather, minus 12. And that's the same as 81 over 4 minus 12. I think I'll go over that again in a second or two. 6 plus 1 over 6 is the same as 37 over 6 minus, now this numerator is the same as 81 over 4 minus 12. So let me do that here. 81 over 4 minus 12, which is simply 81 minus 48. That's 81 minus 48. 81 minus 48 is, that's 33, if I'm not mistaken. Yeah, 78. Yeah, that's 33. So the answer is 33 over 4. So this is going to be 33 over 4 minus 33 over 4 divided by 6 means times 1 over 6. So what does that give us? That's the same as, that's equal to 37 over 6 minus 37 over 6 minus 3 here 11, 3 here 2. That's minus 11 over 8. I think that's correct, and that's equal to, the LCM is 24. 6 and 24 is 4 times 37. That's 120, 148 minus 8 and 24 is 3 times 11 is 33. So that's the same as 100, and that's 115, if I'm not mistaken. I think that's correct. 115 over 24. Yeah, that's correct. Over 24. So the product of the no roots is 115 over 24. Now the equation whose roots are alpha minus 1 over alpha and beta minus 1 over beta is therefore x squared minus sum of roots, which is sum of the new roots, which is, what did I get for the sum? Let's go back to that. The sum of the new roots gave us minus 15 over 4, which is minus 15 over 4 plus product of new roots. Product is 115 over 24. No, x squared minus sum of new roots times x plus product of new roots, which is 115 over 24 equals 0. Don't forget that the new roots are x minus 1 over alpha and beta, alpha minus 1 over alpha and beta minus 1 over beta. We want to show that the equation whose roots are x alpha minus 1 over alpha and beta minus 1 over beta is 24x squared plus 90x plus 115. Let's see if this will give us that. So to clear the fractions, what do I do? Or before I clear the fractions, let me write this. That will be x squared plus 15 over 4x plus 115 over 24 equals 0. Equals 0. And now we multiply through by 24 to clear the fractions. And that gives us 24x squared plus 90x plus 115 equals 0. And that is correct. That is absolutely right. Yeah, that's absolutely correct. So the equation whose roots are alpha minus 1 over alpha and beta minus 1 over beta is actually 24x squared plus 90x plus 115 equals 0. Now to question B. That looks a bit tricky, but it's not difficult if you are careful enough and you're able to simplify. You take your time. Find the value of alpha, beta, into bracket 1 over alpha squared plus 1 over beta squared. It's a continuation of a question. So we're using the original equation, which is 2x squared plus 9x plus 12 equals 0. Now, how do we do this? This is the same as alpha beta into brackets. The LCM is alpha squared beta squared. And that's going to give us beta squared plus alpha squared, which is equal to alpha beta into bracket. I know that alpha squared plus beta squared plus alpha squared is the same as alpha squared plus beta squared, which is simply alpha plus beta all squared. Alpha plus beta all squared minus 2 alpha beta. That's the numerator all over. Alpha squared beta squared can be written as the square of alpha beta. And this is equal to alpha beta is 6 into bracket. Alpha plus beta is minus 9 over 2, don't forget. All squared minus 2 alpha beta, which is minus 2 times 6, all over the square of alpha beta, which is 6 squared. And this is the same as 6 into bracket 81 over 4 minus 12 all over 36. Now what's 81 over 4 that's 6 into bracket. What's 81 over 4 minus 12? That's the same as that's 40. Okay, that's the LCM is 4. That's 81 minus 48, which is 33 over 4. That's 33 over 4. So we're doing 33 over 4 divided by 36. 33 over 4 divided by 36 means times 1 over 36, which is equal to 3 here 11, 3 here 12. And that simply means 6 times 11 over 48. 6 here 1, 6 here 8. And the answer is 11 over 8. Very, very simply. Now that's, okay, that's B Roman figure 1 actually. There's a B Roman figure 2. That's B Roman figure 1. Now let's go to B Roman figure 2 very quickly. Roman figure 2, find the value of alpha cubed plus beta cubed. Alpha cubed plus beta cubed is the same as alpha plus beta into bracket alpha squared minus alpha beta plus beta squared. Minus alpha beta plus beta squared. And this is the same as, Albert's correct. Yeah, that's correct. And this is the same as alpha plus beta into bracket alpha squared plus beta squared minus alpha beta. That's just a rearrangement. Minus alpha beta. Minus alpha beta. And that's equal to alpha plus beta times alpha squared plus beta squared is the same as alpha plus beta all squared minus 2 alpha beta. That's alpha plus beta all squared minus 2 alpha beta and then minus another alpha beta. So that's actually minus 3 alpha beta. So I can just write that alpha plus beta all squared is alpha squared plus beta squared is same as alpha plus beta all squared minus 2 alpha beta and then minus this alpha beta. So that's going to give me alpha plus beta all squared minus 3 alpha beta. I hope you're not confused. I just want to write everything on that same line. Minus 3 alpha beta. Minus 3 alpha beta. And now we can simplify. Alpha plus beta is minus 9 over 2 into bracket the square of minus 9 over 2 minus 3 times alpha beta, which is 6. And then we have minus 9 over 2 into bracket 81 over 4 minus 18. What's 81 over 4 minus 18? The LCM is 4, and that's 81 minus 72. That's correct. Minus 72, which is going to be 9/4. Yeah, that's correct. 9/4. You have to be very careful not to make mistakes with your symbol addition and subtraction. Now, that's minus 9/2 times 9/4. Yeah, times 9/4, and that's equal to minus 81/8, and that's alpha cubed plus beta cubed. Now we go straight to the next, which is number 2. If alpha and beta are the roots of the quadratic equation ax squared plus bx plus c equals 0, where a and b are a, b, and c are constants, express 1 minus alpha cubed times 1 minus beta cubed in terms of a, b, and c. I think that's supposed to be easy. The equation is ax squared plus bx plus c equals 0, and alpha and beta are its roots. That means alpha plus beta is minus b over a, and alpha beta is c over a. Now, how do we write 1 minus alpha cubed times 1 minus beta cubed in terms of a, b, and c? I write that well. 1 minus alpha cubed. Now, that's equal to 1 minus beta cubed minus alpha cubed plus alpha cubed beta cubed. And that means 1 minus, into brackets, beta cubed plus alpha cubed, and I can write alpha cubed beta cubed as the cube of the product of alpha and beta. Yeah, the cube of alpha beta, and that's simply the same as 1 minus. Now, what is alpha cubed? Beta cubed plus alpha cubed is the same as alpha cubed plus beta cubed. Let me just rewrite that. So it's unnecessary, but I'm just writing it so we don't get confused at all. So alpha cubed plus beta cubed plus alpha beta, the cube of alpha beta. Now, what is alpha cubed plus beta cubed? Let me find that separately. Alpha cubed plus beta cubed is equal to alpha plus beta times alpha squared minus alpha beta plus beta squared, and that's the same as alpha plus beta. I know that, yeah, alpha plus beta, let me write it this way, into bracket alpha squared plus beta squared minus alpha beta, so which is equal to alpha plus beta into bracket alpha squared plus beta squared is the same as alpha plus beta all squared minus 2 alpha beta. So if you subtract another alpha beta from that, it will now be alpha plus beta all squared. If you subtract alpha beta from this, you are going to get alpha plus beta all squared minus 3 alpha beta. How about some confusing? Alpha squared plus beta squared is the whole of this minus this alpha beta will now make it alpha plus beta all squared minus 2 alpha beta minus alpha beta, and that's going to be alpha plus beta all squared minus 3 alpha beta. Now we can write down, and that's the same as alpha plus beta. Okay, that's just it. That's alpha cubed plus beta cubed. Now that's what I'm going to write here. So that simply means 1 minus, okay, I think I can now continue. 1 minus alpha, so that simply means 1 minus alpha cubed into bracket 1 minus beta cubed, which gave us 1 minus alpha plus beta all cubed. That gave us this. I think I can just put that there. It gave us this, yes. 1 minus alpha cubed plus beta cubed plus the cube of alpha beta. Yes, 1 minus open bracket alpha cubed plus beta cubed close the bracket plus the cube of alpha beta and that's equal to, now I found alpha cubed plus beta cubed, that will be 1 minus alpha cubed plus beta cubed is alpha plus beta, 1 minus open bracket alpha plus beta times, okay, alpha plus beta, yes, times alpha plus beta all squared minus 3 alpha beta. What kind of bracket am I going to use here? I think I should use the okay, curly bracket here. So that's alpha plus beta all squared, no, alpha plus beta, this is it, I'm not getting confused, this is alpha cubed plus beta cubed, this is alpha cubed plus beta cubed. So that's alpha plus beta into alpha plus beta all squared minus 3 alpha beta, alpha plus beta into alpha plus beta all squared minus 3 alpha beta. The space is quite small, let me rewrite it. That's equal to 1 minus alpha cubed plus beta cubed is the same as alpha plus beta into bracket alpha plus beta all squared minus 3 alpha beta, and then plus the cube of alpha beta. Now we know alpha cubed plus beta cubed. Alpha cubed plus beta cubed is alpha plus b is this alpha plus beta into bracket alpha plus beta all squared minus 3 alpha beta. So we can now continue. That simply means 1 minus alpha cubed times 1 minus beta cubed, which is the same as 1 minus open bracket alpha cubed plus beta cubed plus the cube of alpha beta plus the cube of alpha beta will now be equal to 1 minus, what is alpha cubed plus beta cubed? Let me use this kind of bracket, alpha plus beta. That's going to look a little clumsy, but it doesn't make it difficult. Into bracket alpha plus beta all squared minus 3 alpha beta. Just trying to squeeze in. Or let me do this. Maybe it will be clearer this way. 1 minus, okay, alpha cubed plus beta cubed. That is alpha plus beta into bracket alpha plus beta all squared minus 3 alpha beta. Close the bracket here and put the same here, curly brackets there. Now plus, that's all, plus what? Plus the cube of alpha beta plus the cube of alpha beta. So the whole of this represents alpha cubed plus beta cubed. So 1 minus alpha cubed times 1 minus beta cubed is this, and that's the same as 1 minus this, which represents alpha cubed plus beta cubed. That's this which represents alpha cubed plus beta cubed plus the cube of alpha beta. So that's clear. If you take your time to check that again, you get what I did. You get what it is. Now we can move on. That's equal to alpha plus beta is minus b over a. That's 1 minus open bracket minus b over a. We're finding it in terms of a, b, and c. Minus b over a into bracket the square of minus b over a. The square of minus b over a. Just trying to make that as clear as possible. That space might not contain it. I think I should do it this way. 1 minus, now we have a curly bracket alpha plus beta, which is minus b over a into bracket the square of minus b over a minus 3 times alpha beta, which is 3 times c over a. 3 times c over a, and the bracket closes there. Can make that a little smaller, and close the bracket with this. 3 times c over a, which is 3 alpha beta, plus the cube of alpha beta, that's c over a. That's the cube of c over a. Now where do we go from there? That's equal to that's equal to, don't forget the 1 minus, let me still put the same bracket, minus b over a into bracket the square of minus b over a is the same as b squared over a squared, minus 3 times c over a is the same as minus 3c over a, plus c cubed over a cubed. C cubed over a cubed. Now that's equal to 1 minus, let's simplify, 1 minus, let me just do that, open bracket, minus b over a times, what is b squared over a squared minus 3c over a. Can do that here. B squared over a squared minus b squared over a squared minus 3c over a. The LCM is a squared. That a squared in a squared is 1 times b squared minus a squared divided by a is a times 3c, that's 3ac. So this is the same as b squared minus 3ac over a squared. B squared minus 3ac over a squared, and that will be plus, let's see, that's plus c cubed over a cubed, plus c cubed over a cubed. Can we simplify further? That's equal to 1 minus, now if I expand the bracket, if I open the bracket, I'm multiplying this by this, and that's going to give me minus b cubed minus b cubed. Let me even do this. There should be a bracket here. 1 minus, open bracket, minus b cubed plus 3abc over a cubed a raised to power 3 plus c raised to power 3 over a raised to power 3, and that becomes 1, that's equal to 1 plus b cubed minus 3abc over a cubed plus c cubed over a cubed. We can leave it that way simply, or if we like, these two fractions have the same denominator, so we can put them together as a single fraction as 1 plus b cubed minus 3abc plus c cubed over a cubed. And I can just leave my answer that way simply, whether you stop here or here, it's still the same thing. You can express the answer in whatever form you choose to, as long as it's the same as what it's supposed to be. You'll get the final answer. So that's it, very, very simply. And we take a breather and be back shortly. Thank you very much, and see you in the next. Bye bye.